Steve, and you're here in the office of the Always Believe House. Oh, yesterday we talked about parallel lines, and today we're going to talk about perpendicular lines. Perpendicular lines make an upside down T. So let's get going. We're going to talk about perpendicular lines and how do you write equations with lines that have perpendicular slopes. Sounds like fun, huh? So a magical whiteboard appears, and we are going to rock and roll and get this down. Okay, so we have our notes out here. Perpendicular lines are lines that intersect to form a 90-degree angle. Okay, the symbol for perpendicular is this. Okay, that's how you write the symbol of perpendicular. Instead of writing out perpendicular, I'm going to draw that symbol. Okay, based on this definition, highlight or circle the perpendicular lines in the figures below. So this would be perpendicular. This right here would be perpendicular. This would be perpendicular. And this right here. Hopefully your house is perpendicular, okay? Hopefully it forms a 90-degree angle with the ground. So perpendicular shapes are all around us in real life. The room you're sitting in has perpendicular angles for the walls, okay? Most of them, okay? Let's keep going. Okay, now then we're going to look at the rectangle and get the slopes, okay? So which pair of lines should have the same slope? Two of these lines are parallel. So the two lines that are parallel are R and S and T and U, right? Those two lines should have the same slope because if this is a rectangle, the opposite sides won't meet, will they? So I'm going to zoom in on this so you can see it better. And we are going to get the slopes of all these lines. So I'm going to write down R, S, T, and U, and we're going to write down the slopes. So for line R, I need to find the two grid points, and we'll use this grid point and this grid point. So remember, when you do slope, you go left to right. You go left to right. So to get from my left point to my right point, I'm going to go down and to the right. And I went down 1, 2, 3, and I went to the right 2. So the slope of line R would be -3 over 2. Go with me? So I went down 3, right 2 to get to that line, didn't I? Now then, let's get line S. Line S is right here. I'm going to go down and to the right, aren't I? I went down 3 and to the right 2, didn't I? So line S would also have a -3 over 2 slope. Now then, let's get line T. Line T is not going down, it's going up. And notice that line T forms a dot here, here, and here. So I'm going to go from my first dot to my second dot all the way to the third dot. So I'm going to start at this dot, go up, and then to the right. I went up 2 and right 3, didn't I? So this slope would be 2 over 3. And lastly, line U, well, I'm going to go from here to here. I'm not going to go all the way across. So I'm going to go up and over. I went up 2, right 3, so my slope's 2 over 3. So now I have my slope. So I'm going to zoom out, okay, and let's write these slopes in here. So line R has a -3 over 2 slope. Line S has a -3 over 2 slope. Notice that line R and line S are parallel, aren't they? Line T would have a 2 over 3. Oh, line T would have a 2 over 3 slope, and so would line U, right? So we have all those slopes. Line T, line U are parallel. Line R and line S are also parallel. Now then, list the pair of perpendicular angles from the figure. Okay, so the perpendicular angles, and I'm going to delete all this. Okay, do we have two angles that are perpendicular in here? Let's do this. Draw a perpendicular symbol here and draw a perpendicular symbol here. Or let's do it this way. So we should know that a rectangle has 90-degree angles, right? So this angle right here is formed from line R and line T in it. So let's look at line R and line T. And then this 90-degree angle is formed from line U and line S. So let's look at line U and line S. So line R has a -3 over 2 slope, and line T has a 2 over 3 slope. Line U has a 2 over 3 slope, and line S has a -3 over 2 slope. And these angles are perpendicular. Notice that the only numbers in the slopes are 2 and 3, aren't they? Okay? So what conjectures can you make about this, okay? So pause the video, write down what you notice about these slopes. So pause the video now. And now we're going to write down our slopes, okay? So the slopes are opposite signs. One's negative, one's positive. That makes sense because they have to form a 90-degree angle. And the fractions are flipped. And we're going to talk about what that means in a minute. So the fractions are flipped and the signs are opposites, okay? So go down here. This is how you would word this. Slopes of perpendicular lines are opposite reciprocals. That is how you word this, okay? Reciprocal means you flip a fraction. Okay, to find the slope, flip the fraction and change the sign. That's how you get perpendicular slopes. So you're going to flip the fraction and change the sign. Okay, let's keep rocking and rolling, and that TV is shining right in on me. That is not good. Hold on. There, that's better. Got to adjust that so I don't have light on me. Let's keep going. The sun's setting into the office. Okay, now then, let's look at this one. So we're going to find the slope of a line perpendicular. So let's get the slope first. So this slope is 4 over 5 in it. This is the way I teach this. Draw 4 over 5, draw an arrow, and put a perpendicular symbol. So I have a slope of 4 over 5, and I want to get a perpendicular line to that. So I'm going to flip the fraction and change the sign. So if I change the sign will be negative. If I flip the fraction, I get 5 over 4. So these two slopes would form a 90-degree angle. Pretty easy stuff. Let's do the next one. The slope of this one's negative 1 over 2. So put negative 1 over 2, draw an arrow, put a perpendicular symbol. How do I get the perpendicular slope? I'm going to flip it and change the sign. So it's going to be a positive 2 over 1 or just a positive 2, right? 2 over 1 would just be 2. Let's go to number 3. Number 3, our slope is 5. So I'm going to put 5 over 1 so you can see this. Draw an arrow, put a perpendicular symbol. We're going to flip this fraction and change the sign. So if we flip 5 over 1, we're going to get 1 over 5, and it's going to go from a positive to a negative. So this would be the perpendicular slope. Let's go to number 4. Number 4 is not written in the correct order. It should be y equal negative 10x plus 17, right? So the slope will be negative 10, won't it? So put negative 10 over 1, draw an arrow, put a perpendicular symbol. We're going to change the sign and flip the fraction, right? So if we change the sign, we have a positive, and if we flip it, we get 1 over 10. So our new slope's 1 over 10. Piece of cake, huh? So all you got to do is get the slope, change the sign, and flip it. You got the perpendicular slope. Now then, this is what the state of Texas wants you to do. The state of Texas is going to give you the equation of a line and a point that another line goes through, and the new line is going to be perpendicular to the old line. So what we're going to do on this, since you know how to use point slope, we're going to get the new slope, we're going to flip the slope, and then we're going to use point slope and switch the line. And on these questions, we want slope-intercept form. Oh, so let's write this down. Our slope is 3 over 4, and we want a perpendicular slope. So we're going to write down 3 over 4, draw an arrow, put a perpendicular symbol. Our new slope will be negative 4 over 3, won't it? And we're going to put m. This will be our x, this will be our y. Now then we're going to plug into point slope. Remember, point slope is y minus y1 equals m parentheses x minus x1. So we're going to fill in here, here, and here, aren't we? So let's write that down. Y blank equals blank parentheses x blank. We need to plug 3 numbers in. The first number we're going to plug in is this y. What is the opposite of a positive 3? It's a negative 3 in it. The next number we're going to plug in is the slope. It's going to be negative 4 over 3. And the last number we're going to plug in is our x, which is 0, so we're going to put minus 0. Technically, you don't have to put the 0, but let's put it there for now. Now then, we have a fraction, don't we? And remember, the denominator goes left, the numerator goes right. So to get rid of that fraction, we're going to put 3, 3, and 3. These 3's will cross out, and this negative 4 goes to the right. So do you see what I say? The denominator goes to the left 2, the numerator goes to the right 2. Now then we're going to multiply 4 times. 3 times y is 3y. 3 times negative 3 is negative 9 equals negative 4 times x is negative 4x. Negative 4 times 0, I'm going to put plus 0. The next step is to move that 9. So I'm going to take the 9 and move it across. And I'm going to end up with 3y equals negative 4x plus 9. And my last step, since I want slope-intercept form, I'm going to divide by 3. If I want standard, I'm going to move the 4x, aren't I? So when you get to here, you can make either standard or y-intercept. We want slope-intercept. So we're going to divide every term by 3. And that's going to give us y equals negative 4 over 3x plus 3. And our new slope is negative 4 over 3. Ho, 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 ho. Fun, 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 fun. That's just like eating a mega stuffed Oreo dipped in ice cold milk. Yum, 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 yum. Let's go to number 6. Once you get this system down, it is going to click. Y'all are doing well with this, okay? Doing good with it. We're going to keep working on it. Okay, the same problem. We want a line perpendicular to this one, and it goes through this point. That's our x and our y. So let's write down our slope, which is negative 1 over 3. Draw an arrow, and we want the perpendicular slope. So we're going to change the sign from negative to positive and flip. We would just get 3 over 1 or 3, wouldn't we? That is going to be our m, isn't it? So we know our m, our x, and our y. Now we're going to plug into point slope. Okay, so when we plug into point slope, the opposite of positive 7 is negative 7. Our slope is 3. The opposite of negative 2 is a positive 2. So you just got to plug those 3 numbers in, and the x and y will switch signs. Now then, we don't have a fraction here, so this won't be hard. So the 3 is going to get bluebell trucked or distributed to the x and the 2 in it. So we're going to have y minus 7 equals 3x plus 6. Piece of cake. Now then, we want y-intercept form, so all we got to do is move this 7 over. Every single time, that's the first step, is to move that number over. So we're going to end up with y equals 3x plus 13, and our new slope is 3 in it. Piece of cake. Ho, 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 ho. You are learning math with more power. Oh, let's go to number 7. Oh, got a little bit too much power on my Zoom. Okay, let's go to number 7. So let's find our slope. Our slope is right here, and this is going to be our x and our y army. And we want a perpendicular line. If it's parallel, the slope won't change, will it? So our slope is 6. I'm going to put 6 over 1. Draw an arrow and put a perpendicular symbol. And we're going to flip it and change the sign. So the 1 over 6 will turn negative, or the 6 over 1 will turn negative, and it's going to get flipped to 1 over 6. That is going to be our slope in it. So we know our slope, we know our x and our y. We're going to plug it into point slope. So we're going to get y, the opposite of minus 5 is plus 5, equals, our slope is negative 1 over 6, parentheses x, the opposite of plus 12 is minus 12. Now then, when we're right here, we have a fraction. The denominator goes left, the numerator goes right. So we got to get rid of this 6, so we're going to do 6, 6, and a 6. That's going to cancel out the fraction, and this negative 1 goes to the right, doesn't it? Ho, 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 ho. Now we're going to multiply. So 6 times y is 6y. 6 times 5 is 30. Equals negative 1 times x is negative x. Negative 1 times negative 12 is a plus 12. Now then, the next step is to move the number on the left. So we're going to take this 30 and move it to the left, and that's going to be a minus 30 and a minus 30. Oh! Now then, we're going to subtract and do our arithmetic. 6y equals negative x minus 18. Ho, 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 ho. Now then, we're going to divide, right? If we wanted standard, all we would have to do is move the x to the left. We want y-intercept though. So we're going to divide everything by 6. And that's going to give us our equation. It's going to be y equals negative 1 over 6x minus 3 in it. And our slope is negative 1 over 6 in it. Notice we do all of that arithmetic and the slope doesn't change, does it? Pretty awesome stuff. So this is critical. You got to get the new slope, plug in a point slope, and switch it. Y'all can do this, okay? This is going to make you a very strong algebra student because you're doing a lot of skills right here. Let's keep going. Sketch a dotted line perpendicular to the x-axis and a solid line perpendicular to the y-axis on the graph. Then write an equation for the line next to it. Okay, so sketch a dotted line perpendicular to the x-axis. So I'm going to put it right here, and I'm just going to do a dotted line through here. And these two lines are perpendicular, aren't they? This equation would be, and I'm going to zoom in, 1, 2, 3, 4. This line would be x equal negative 4, and it's perpendicular to the x-axis, isn't it? Notice if it's perpendicular to the x-axis, it will go through the x-axis. If it's perpendicular to the x-axis, it will go through the x-axis. That means your equation will be vertical because it's going to go through it. If it's parallel to the x-axis, it's going to be flat. This is very confusing. So you have to know this terminology. Now then, we're going to put a solid line to the y-axis. So I'm going to go over here and let's put a line right through here. Notice that this line, and let me go through a certain point here. I did a bad job on that. And I'm going to go down one. Let me go to here. Okay, so this crosses the y-axis at 2, so I got y equal 2, and it is perpendicular to the y-axis in it. Notice that if it's perpendicular to the y-axis, it will go through the y-axis. So the equation will have y equal. If it goes to the x-axis, it's going to have x equal. Now then, let's go over here. A line perpendicular to the x-axis will be vertical and have an undefined slope. Oh! A line perpendicular to the y-axis will be horizontal and have a slope of 0. Let me spell that right. That is a huge concept, okay? So if it's perpendicular to the x-axis, it's going to be x equal. Perpendicular to the y-axis, y equal. Okay? You might want to write this down. Perpendicular to x-axis, it's going to be x equals something. Perpendicular to the y-axis, it's going to be y equals something. Okay? That's important to know. Let's go to number 8. Write an equation for the line passing through point -8. Now then do this. Put x and y. Perpendicular to the x-axis. If it's perpendicular to the x-axis, it's going to have x equals something. What is the x in that ordered pair? It's -8. That's how easy that is. If it's perpendicular to the y-axis, it's going to have y equals something. What is the ordered pair y in that ordered pair? It's 11 in it. So the answer is going to be y equal 11. Okay, so if it's a line, if it goes through if it's vertical, it's going to have x equal your x number. If it's flat, it's going to have y equal your y number every single time. It's not that hard. Make sure you're labeling your point. The answer has to be either x equal -8 or y equal 11. If it's vertical or horizontal, every single time. Let's go to number 9. Write the equation of a line that is perpendicular to the line B and passes through -4, comma 5. So let's find the slope of this line. We got to find some grid points, don't we? And notice this line is just going down 1 over 1, right? So the slope, so put down m equals -1, draw a bar, put a perpendicular slope. What happens if we split 1 over 1? We just get 1, but it won't be -1, it'll be +1, won't it? Now then, let's plug in the point slope. This is our x, this is our y. So we'll have y minus 5 equals 1, parentheses, x minus, or x plus 4. Okay, so I'll flip my y and my x, and the slope is just 1. This is going to be a piece of cake here because the slope's 1. So when I distribute this 1, nothing changes, does it? So I'm going to have y, let me do this right. Y minus 5 equals x plus 4. Now then, the next step, every single time, you're going to take this number and move it over, aren't you? So add 5 to both sides, and we're going to get y equals x plus 9. Ho, 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 ho. F-U-N, fun, fun, fun. Oh! And now the last one, we got to figure out if these two lines are perpendicular. So we need to get the slopes and then see if they're opposite reciprocals. So let's get the slopes. Let's do line F first. Line F goes through here and here. So the slope is going to be 2 over 1, right? Or 2. Now then let's get line G. Line G goes through here and here and here. So its slope is negative 1 over 1 or negative 1 in it. So our slopes are 2 and negative 1. Are they they're opposite, but are they reciprocals? They are not. So you're going to write down the two lines are not perpendicular because the slopes are not opposite reciprocals. And you can do that on your own. I hope you have thoroughly enjoyed this lesson. You've learned about perpendicular slopes and that they're opposite reciprocals. Then you learn how to plug in a point slope and switch that to slope-intercept form. And you are a better person for it. Remember, you are amazing, you are created to do wonderful things, and you are awesome.